Hello, in this lesson we're looking at Chapter 3, Section 5, Using Properties of Parallel Lines. Our objectives are to use properties of parallel lines in real-life situations and construct parallel lines using a straight edge and a compass. Theorem 3.11. If two lines are parallel to the same line, then they are parallel to each other. This means that if line P is parallel to line Q and line Q is parallel to line R, then we can get rid of the middle guy, which is Q, and just say that line P is parallel to line R. Theorem 3.12. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other, meaning that if line M is perpendicular to line P and line N is perpendicular to line P, then we can conclude that line M is parallel to line N. Example 1, explaining why fence posts are parallel. In the diagram at the right, each fence post is parallel to the fence post immediately to the right. Explain why the fence posts on each end are parallel. So basically what this is saying is that this fence post line 1 is parallel to line 2, and line 2 is parallel to line 3, and line 3 is parallel to line 4, and we want to explain why line 1 is parallel to line 4. So you're given that line 1 is parallel to line 2, and line 2 is parallel to line 3. By theorem 3.11, we can say that line 1 is parallel to line 3 by getting rid of the middle guy because line 2 is in both of these statements. And then you are also given that line 3 is parallel to line 4. Because line 1 is parallel to line 3 and line 3 is parallel to line 4, we can get rid of the middle guy, which is line 3, and use theorem 3.11 again to conclude that line 1 is parallel to line 4. Example 2, building a picture frame. You are building the picture frame in the diagram at the right. You cut pieces of wood such that the measure of angle 1 and the measure of angle 4 are 30 degrees. So let's go ahead and write that down. Angle 1 is 30 degrees and the measure of angle 4 is 30 degrees. And the measures of angle 2 and 3 are 60 degrees. So 2 is 60 and so is 3. Prove that the right and left sides of the frames are parallel. So we're given that the measure of angle 1 is 30 degrees, the measure of angle 2 is 60 degrees, the measure of angle 3 is 60 degrees, and the measure of angle 4 is 30 degrees. We are to prove that line segment PS is parallel to line segment QR. So we want to prove that line segment PS, which is this line over here, is parallel to line segment QR, which is this line over here. So here's our proof. Anytime we start our proof, we always start with our given. We are given that the measure of angle 1 is 30 degrees, the measure of angle 2 is 60 degrees, the measure of angle 3 is 60 degrees, and the measure of angle 4 is 30 degrees. That's our given. By the angle addition postulate, we can find the measure of angle PSR, which is this angle over here, by taking the measure of angle 1 and adding it to the measure of angle 2. We can do the same thing for angle QRS, which is this angle over here, by taking the measure of angle 3 and adding it to the measure of angle 4. When we simplify, 30 plus 60 gives me 90 degrees, and 60 plus 30 gives me 90 degrees. So the measure of angle PSR is 90 degrees, and the measure of angle QRS is 90 degrees. That's using the substitution property and simplifying the measures. So the substitution came from having 30 plus 60, which gives us 90 degrees, and 60 plus 30, which gave us this 90 degrees. Because we know that 90 degrees means that the angles are right angles, we can say that angle PSR is a right angle, and we can also say that angle QRS is a right angle, and that's using the definition of a right angle. Because we know that right angles are created by perpendicular lines, we can say that line segment PS is perpendicular to line segment SR and line segment QR is perpendicular to line segment RS. That's using the definition of perpendicular lines. By theorem 3.12, which says that if two lines are perpendicular to the same line, then they are parallel to each other, we can say that line segment PS is parallel to line segment QR, and that's in a plane. If we have two lines that are perpendicular to the same line, then those two lines are also parallel. All right, checkpoint problem number 1. Are all of the vertical lines parallel? Explain. Our next is an activity on constructing parallel lines. To review the process of constructing parallel lines, there's a website over here that goes through it. Step 1. Draw a line through R and across PQ at an angle, creating point J. Step 2. With a compass width about half of JR and the point on J, draw an arc across both lines. Step 3. Using the same compass width, repeat at point R. Step 4. Set the compass width to the lower arc. Step 5. Move the compass to the upper arc. Mark off an arc to make point S. Step 6. Draw a straight line through R and S. And there you have it. The line RS is parallel to PQ. All right, that's it from me. I'll see you all soon.